In this video, we want to discuss the identity matrix. The identity matrix is a square matrix that has along the main diagonal only ones, and then you have zeros everywhere else. Now, think about things that are identities. So you have the additive identity with just regular numbers, which is 0. And that means that you can add 0 to anything and it doesn't change the result. Then there's the multiplicative identity, which is 1. So you can multiply anything times 1 and the result stays the same. So with matrices, their identities are going to look like this, which means that if I multiply things, it shouldn't change my matrix. So when you have the little subscript right here that says n, that's just telling you what the dimensions would be. So like an n by n. So when you see I2, that means you have a 2 by 2, or so you have square matrix, ones along the diagonal, zeros everywhere else. So I want us to compute these following things down here. What is I3 times A? Well, think about what that's going to look like. I3 is this square matrix. Again, you have ones along the diagonal, zeros everywhere else. And if I multiply this times the matrix A, watch what happens. I mean, it's the identity, so we would expect that if we multiply times the identity, nothing changes. But let's verify that. If I were to take this first row, like we've been doing with matrix multiplication, and I see this as putting 0, 1, and the zeros, right? So 1 times negative 3 gives me negative 3, plus the 0 plus 0. Nothing changes. Go to the next one. 1 times 4 is going to be 4, plus 0 plus 0. All right. And then if I go to the next row and I do 0, 1, 0. 0 times negative 3 is 0. 1 times 5 is 5, and then 0. And here on the other side, 0 times 4 is 0, and we get negative 1 plus 0, so you're done. And I bet you know what's going to happen for the last row, right? I mean, shocking absolutely no one. So if I take that 0, 0, 1, and I multiply that here, we get 0, 0, and we're just left with 2. Same thing here for the last column. 0 times 4, 0 times negative 1, 0, and then 1 times 5, and we get 5. So you multiply times the identity matrix, and nothing changed. If I were to change things around and do matrix A times the identity matrix based on the 2 by 2 matrix, right? So that's going to be negative 3, 4, 5, negative 1, 2, 5, times the 2 by 2 identity matrix of 1, 0, 0, 1. So remember when we talked about rows and columns. So A has dimensions 3 by 2, and of course the identity matrix here is 2 by 2. We said that the columns of the first one have to match the rows of the second one, otherwise you can't do the product. In the previous example, you have a 3 by 3 times A, which has 3 rows and 2 columns. And we see here that these guys have to be the same so that we can do the product. Well, not to spoil anything for you, but I think you know what's going to happen. If I take that first row and I rotate it vertically, and I multiply this, oh, I think I need more room. So negative 3 times 1 is negative 3, but then you get 0. Negative 3 times 0 is 0, and then 4 times 1 is 4. And you do that for all the other pieces, all the other rows, and you're going to find out that nothing changes because you are multiplying times the identity. That's it. And similarly, when I'm working with matrix B, if I do that times the identity, Again, it's the identity, so nothing changes. It's going to stay just like that. Okay? If you don't believe me, try it on your own and see what you come up with. And you're going to see that nothing changes. All right. Well, what we want to look at next is how do we come up with an inverse? How do we find a way to undo what a matrix is doing? It's kind of fun, so come back. All right.